Welcome humans to ETSK Tutorials. So today's tutorial is going to be going over how to use physics layers inside of Unity 3D. So basically what physics layers are used for is basically making certain objects ignore other objects while not ignoring other objects. And this can be really useful for certain things like just general behavior of your game. Like let's say you want enemies to be able to walk through certain objects, or maybe you want the player to be able to see certain objects but not interact with them because they would get in the way a bunch. Or maybe you don't want physics objects to interact with the gun that the player is holding, but you want it to interact with something else. I mean, there's an infinite number of scenarios where it would be useful in that respect. But in another more common respect of what physics layers are useful for is performance optimization, because it can make your game run a lot faster if you have a lot of rigid bodies actively moving around in your scene, because basically those rigid bodies, instead of looking at everything that is inside of the game, it will only look at what it absolutely needs to according to you. So that is what we're going to be learning in this episode. So let's go ahead and get started. So far I've made kind of like a slide, and I've made it all transparent so that we'll be able to see. We're going to drop some balls through it, and basically what I want to do is I want to make some balls go through this wall and some not, and that will be the basics of how physics work. And then I'm also going to create a high performance scenario where I just spawn a bunch of balls, and I will show the difference in performance optimization when you spawn a bunch of balls, or any rigid body really, that are all colliding with each other or ignoring each other, but interacting with other objects in the scene and stuff like that. So let's go ahead and get started, and let's talk about layers real quick. I mean, I guess there's really not much to say about layers. They're kind of like tags, except not really. And the main thing that you might know them for is being able to turn certain objects on and off. Like in here, like let's say let's create a new layer. Let's select all of these cubes, and let's go to layers, and let's go to add layer. So the layers and tag menu are kind of in the same place. In case you don't know where to go, you go to edit, project settings, where is it, tags, and it'll bring this up in the inspector. And of course you can also just under layer go to add layer. I wonder if you can do it from here. Yeah, you can also do it from here, edit layer. So there's a lot of different ways to get to this menu, but tags and layers share the same menu. So there are a limited number of layers that you can possibly use in your game, but you do have a lot available to you. You have the default, I guess 8. There's 8 by default. So I guess there's a lot. I don't know, but I guess it starts off with 8, and there are some default layers, and there are your own custom layers, and those are all of them here. So you do have a limited number, unlike tags. So just be cautious of that. You do get enough of them to get the job done, whatever you're doing, but for whatever reason, you do have a limited number. Okay, let's move on. So let's just call this test layer, and let's just do one test and call it test layer. And let's select all of the cubes in our scene, and let's set the not all of them. Let's do all of them except for that orange cube, which I named permeable cube, because some of the rigid bodies will go through it and some of them won't. But every cube besides that one, we're going to set onto the layer test layer, and then we can go up here to layers, and we can turn that layer on and off. So that is basically a really quick summary of what you can do with layers and how you can use layers to basically get a bunch of things out of your way while you're working, so that your workspace is a little bit cleaner and you can see better, basically. So that is the first use of layers. But now let's create one more layer, and let's call it permeable, I guess. And this layer will have some rigid bodies go through it and some not. So let's call this let's call it permeable wall, I guess. And let's make another one called permeable. Am I even spelling permeable right? Can't see. My mouse is in the way. Permeable ball. All right, there we go. All right, so let's select this, and let's make it on the layer permeable wall. All right, now what we should do is let's actually zoom into that so that we can create a sphere that is in the correct placement. And I just want to move it up just a little bit. I think that's where I'm going to want to have it be. And then let's go to add component, physics, rigid body, and then let's run the game really quickly to see what happens. and it just rolls and stops. So yes, that is basically what physics does if you don't do anything with the physics layers. Like if you just leave them all by default, all colliders collide with all other colliders. So let's fix that. What we are going to do, actually no, I need to change the sphere and I need to rename this. Actually no, I'm going to duplicate it so that we have two of them. So duplicates, and I'll just move. The one that's higher up will be the permeable one, and we will name this Permeable Ball. So actually I got to move it over a little bit because then otherwise it might just get stuck on top of it. So that should be good. It's gonna, I just got to check. It will fall inside of the slide, right? Now it will. All right, cool. So one of them is actually, let me just create a new material. So let's duplicate this and let's go ahead and not make it transparent, and let's make it like bright red. All right, so let's make the permeable one bright red. So the bright red one will go through the wall. So what we need to do is we need to go to Edit, Project Settings, Physics, and then we have this cool thing right here. And actually, why don't let me do something really cool with XSplit for a second. I'm just gonna do that. I'm gonna do that, and now you can see it bigger. So yes, it's pretty important, so I want to make sure that you can see it very well. So these, as you can see, we have all of our layers listed up here, starting with default and going all the way down to permeable ball. And then the same thing vertically, starting with default and going down to permeable ball. So if you'll notice, if you take any two items on these two identical lists, one's just listed horizontally and one's listed vertically, if you find where they cross and then check or uncheck, you are checking or unchecking whether or not those two layers will interact with each other inside of physics. So what we are going to do is we want to make sure the permeable wall does not interact. Wait, permeable wall. No, there it is. Permeable wall and permeable ball will not interact with each other. We can also do stuff like we can make permeable balls not interact with other permeable balls. We can also make permeable walls not interact with other permeable walls. But for now, we're just going to uncheck that single one. So I'm going to get that out of the way. And then let's see, I named it all correctly? Yeah, I think it's all good. So let's give it a test and see if I did everything correctly. And yes, you see it went through. So that can be useful in certain situations. So now what we're going to do is we're going to create a script. So create JavaScript, and we'll call this create balls. And there's a lot of ball puns in this episode, aren't there? So let's open that up and let's create a script that is basically going to be on a timer that we will specify. Actually, let's call this var wait time, and let's make this a float and make it by default be 0.1. So that will be 1 or 10 balls a second, and then track time, I guess, float, and let's have it by default be 0, so that the game creates a ball when it starts up right away. Oh, and we are also going to want a ball prefab. So var ball, prefab, and we got to make it a game object. All right, cool. So that should be pretty good and ready to go. Let's see. Actually, I will do a little bit of randomness actually, just to make the balls kind of randomize a little bit so that it looks a little bit better. So I'm going to go var random dist, and I will show you. We'll do a little quick lesson in randomization in this episode. So random dist, and we will call it, or it'll be of type float, and let's just have a random dist of 0.5, so that they scatter a little bit when we create them, just for a nice effect, and it will just make the game behave slightly nicer, which then again, this is a tutorial, so it doesn't really matter too much as long as you understand the main concept of the title of this tutorial. Wow, I'm just going on a weird random rant. That's carbonated apple juice, by the way, in case you're wondering. Yeah. Don't drink, kids. All right. So what do we need to do? We need to go, we will do track time minus equal, time dot delta time, And that should be good. So basically track time is going to be counting down at 1 per second. So we're starting off at 0 and it is going to count down at 1 per second. So in 1 second, it will be at -1. At half a second, it will be -0.5, etc. And basically what we're going to do is we're going to say if we are less than 0, then we're going to create a ball and then set the timer to equal wait time so that it just keeps on counting down and down and down like that. And that is how we will create balls at a constant rate. So we need an if statement and say if track time is smaller than or equal to 0. Let's put our brackets in there. Then we are going to I hate this word, instantiate. I think I got, wait, instantiate. Okay, I got it. All right, instantiate a ball prefab. At position, we actually need to do transform dot position plus, and this is where the randomization comes in, vector 3. Nope, it's not a vector 2, a vector 3. And we are going to do random dot range between, let's see, negative random dist and positive random dist. And I'm going to select all of that and I'm going to copy it and comma, control V, comma, control V, bam, and we have our vector 3. Okay, so this is kind of a long line of code, but then we also need to do transform rotation and then bang, bang, bam, whatever. What I meant is we're done with this line of code. So basically, let's break this down into parts. So there's 3 parts to instantiate in case you've never used instantiate before. I'm going to try to sum up as quickly as I can. So basically, instantiate means create. So this is used for just creating things, whether it's an enemy, a bullet, health, ammo, whatever. If you just want to create something, you use instantiate. And you can either instantiate either a copy of a game object that is in your scene or a prefab. In this case, we're using a prefab. A prefab is something that you save inside of your project that is basically a game object that you save that you want to create later. So in this case, it is going to be ball prefab, and we're just going to instantiate some spheres with rigid bodies on them. And then you need to give it the position at which we want to instantiate or create this new game object. So we are going to start off on the position that this game object is at. So we're going to create a game object that's going to be spawning balls. So we're going to create it at that plus a vector 3 that both on the X, Y, and Z axis, it will give a number that is randomly in between negative random dist and positive random dist through the function random.range. So the way that random.range works is you give it a minimum number and a maximum number, and it gives you a random number that is somewhere in between that minimum number and that maximum number. And then you need to give instantiate you need to give instantiate a rotation, and in this case we're just going to copy the rotation of the transform because the rotation in this situation really doesn't matter. Okay, so we're all good. We created a ball. So what we need to do now is reset the timer, and we're just going to do track time equal wait time. And I think that is everything in the script. Should be working. I had no errors. Cool. All right. So let's focus in on that, and I'm going to create, I guess I'll create a cube, even though normally I would create an empty game object, but I just want to make sure that it is easy to visualize what game object I'm creating. But I am going to remove the collider so that none of the balls are going to interact with it, so that cube will just be a way of visualizing where the balls are going to spawn. And then we're going to add a create balls script. And then we added it to this cube, and let's rename this cube ball spawner so that we can see it in the hierarchy. All right, now let's go to create prefab, and let's call this ball. And let's take, which sphere was it? The non-red one. Let's go ahead and drag and drop it right there. And actually, let's edit this prefab. So I'm actually going to create a new material just so that we can visualize it a little bit better. Let's make it like a greenish. All right, yellow. Yellow is good. Let's drag and drop on top of that prefab so that now this prefab will be yellow. And then we need to put it onto a new layer. And let's add a layer and let's just call it ball. Blah, blah, blah. Doesn't matter. Doesn't matter what you name it. I can't think of a good name. We're just going to call it ball random keys. Okay, whatever. So let's go to layer. Let's go to ball, blah, 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 blah. And that ball blah, 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 should pretty much be all set for our intents and purposes. Wait, did I even use that word correctly? I don't know. But we're going to drag and drop this prefab onto the ball prefab inside of the script that we have attached to the ball spawner, as you can see up here. And I'm trying to think if there's anything else. Everything else should be good to go. Let's give it a test and see what it looks like. It should create 10 at a time. And as you can see, it is definitely doing so. So let's take a look at our frames per second. And I actually have a slightly pretty good computer. So we are actually going to have quite a bit of trouble creating a situation in which we are going to be able to make everything lag. So I'm going to have to create a lot of balls. So let's go and let's create like a tray or something like that all of these balls can land in. That's good enough. A floor. They'll just roll off. And actually, let's take this camera. Here's another cool trick. Go to Object, Align with View, and then you can move your camera exactly where you want according to what you see in the scene view. So that's a cool trick, just in case you wanted to know about that. All right, cool. So let's spawn more of them. And let's actually move the ball spawner. Let's move it up a bit. I want it like just out of view. And wait time, let's do 0.01, so 100 balls a second. All right, let's see if we can make the game lag. Oh, it's actually not lagging that much. All right, I'm gonna need to create a lot. All right, let's do 1,000 a second. Heck. Oh wait, I need to go to edit project settings, because really I'm only doing 60 a second because I have VSync on, because we're capping the frame rate. So let's go to don't VSync, so the computer goes as fast as it wants to regardless of your monitor's refresh rate. So now we should be able to create a lot of balls, and now the game should be lagging a little bit. It's not lagging as much as I would like, but it is definitely lagging. We're getting a frame rate of about 150. It looks like it's going to get to about 150. So now it's down to 140, and it's just going to keep getting lower and lower the more balls that appear in the scene. So let's do something kind of tricky. Let's go to Edit, Project Settings, Physics, and remember our ball, blah, 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 the ball, blah, 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 as you can see, it is on the list right here and the list right here, so it intersects right here. So let's just click on Don't Interact, and let's see what happens now. So now when we run the game, you can see that they don't interact with each other, and it looks kind of weird in this situation. And actually, I don't know what's going on. We are getting a lower frame rate. Oh, it is because we are getting an error. Let's see, the two pairs, wait. You created too many pairs. New pairs will be ignored. Okay, I guess I'm just creating too many game objects in the scene. This is a weird situation where I'm trying to make the computer lag. So I guess I'm getting a weird side effect right now. So let's do 100 balls a second, and let's make them a little bit more random. And now let's see what happens. Seems to be going pretty well. Alright, so I'm getting a frame rate of about, I'm going to say, well, it just keeps going down and down, so it's really hard to tell. I'm trying to create like a good scenario where I can prove that this is really happening, but trust me, you can use physics layers to make your game run faster, and this is just one situation. So let's go back to Edit, Project Settings, Physics, and let's actually make them collide with each other, and then let's do a test run. And you can see the frame rate, I can't tell. I don't know. This isn't really a good proof whether or not it works, but trust me, I've done this in games before. It definitely works. It definitely speeds up your game if you use physics layers in the correct situations. This is just kind of a weird situation. It may actually be running faster, but it's just hard to tell. Let's just do one more run and see if you can tell. Seems to be running faster. Possibly. I don't know, but it's just the computer has less rigid bodies that it's actually going to pay attention to. So since there's so many balls in our scene right now, if all of the balls are paying attention to all of the other balls, that's a lot of calculations to make. Whereas if all of the balls are just ignoring all of the other balls and only looking at the environment, then actually let me turn this off because it's probably making the computer lag and the screen recording lag. But what was I talking about? Oh, if it only has to pay attention to the environment and not the hundreds of balls that are in the environment, then that is a lot less calculations that the computer needs to make, and it's going to run a lot faster. So that is how physics layers work. You can use them in lots of different situations. They also work with character controllers. All of this stuff applies to character controllers. So you can make certain objects move through other objects, or you can make rigid bodies move through character controllers. Like, this is really useful if you want a bunch of rigid bodies, but you want them to ignore your main player character because you don't want your player character to try to run through this like pile of rigid bodies or like dropped weapons or stuff like that. Like, you don't want to have to make your player climb over a health pack and have your game be really, really clumsy and difficult to navigate and stuff like that. By just getting those things out of the way so that they're still there, you just physically can't interact with them, so that navigation is just a lot more smooth and less things to run into. So that would be another situation that those would be really useful to use on. So yeah, hopefully you enjoyed this episode. So until next time, I will see you later, and keep making games. I forgot the button again. Wrong button. No, I didn't want to press that button. I wanted to go over here to XSplit, and then I wanted to press this button here. So until next time, see you later. Keep making games.